Hi, my name is Julie Howe, and I am a professor at Texas A&M University. And today I'm going to talk to you about challenges and opportunities for climate-smart agriculture. So today, agriculture is facing unprecedented challenges, as I'm sure you're aware. First, we have a rising population. They're demanding additional food and fiber production and really demanding high-quality food on top of that. And this production is competing for land and water resources. In addition, we're facing climate change. This is reducing the reliability and productivity of our agricultural systems, as well as profitability. And in addition, there's evidence that some of our current systems are contributing to climate change. It's estimated that at least in greenhouse gas emissions, agriculture sector represents about 11% of the emissions, at least in 2020. So what are our approaches to tackle these problems? Well, in the past, we've talked a lot about conservation agriculture. These are supposedly sustainable production systems that conserve resources and improve or maintain soil health and soil quality. Nowadays, we talk a lot more about regenerative agriculture and climate-smart agriculture. In my mind, there are really not a lot of differences among all these systems, particularly between regenerative agriculture and climate-smart. These two really want to improve carbon sequestration, which has benefits to the crop, as well as help mitigating climate change, as well as improving the tolerance of the crops to the climate change themselves. Both of these are designed to improve sustainability of our production systems, as well as improve food security. The only difference to me between conservation agriculture and regenerative and climate smart is that we don't specifically talk about carbon so much in conservation agriculture, even though that's really one of the main drivers behind reducing erosion and conserving resources. So I'm going to talk mostly about climate smart ag, obviously. So climate smart ag, one of the main goals is to increase carbon sequestration. This is to put more carbon or organic matter back into the soil. This has a large benefit to soil fertility because we can recycle nutrients a lot more effectively, and we can improve infiltration and water holding capacity because carbon plays a strong role in soil structure and water holding capacities. So increasing carbon sequestration has an inherent benefit to the soil, but it also benefits climate change because we are helping mitigating climate change by reducing the amount of greenhouse gases in the air. In another option, we also want to reduce greenhouse gas emissions, right? So a lot of that is going back to reducing nitrogen losses because nitrogen, as nitrous oxide, is a major greenhouse gas, and nitrogen fertilizers often contribute to greenhouse gas emissions. Here is a graph of our food sector. You can see that almost 80%, actually a little over 80%, of our greenhouse gas emissions from food production come from our animal and crop production systems. And if we look at what gases that are the main gases, we think of it's nitrous oxide and methane, with carbon dioxide being a minimal one. So while increasing carbon sequestration is very beneficial to helping our soil fertility, taking carbon dioxide and sequestering it is not tackling a lot of the greenhouse gas issues. So we definitely need to think about reducing greenhouse gas emissions as well. As you can see, crop and soil management is around 60%, whereas the animals themselves and are around 40%. Of course, keep in mind that we are producing crops for animals as well. So it probably ends up being around 50-50. So I'm sure most of you are familiar with common climate smart agricultural practices, things like cover cropping, reduced tillage, residue management, fertilizer management, irrigation management. A lot of these translate directly from conservation practices. On the animal side, usually it has to do with pasture, stocking, management, or manure treatment. And that's particularly on those large confined animal operations. And then there are some cases where we're trying to integrate crop and animal production, or sometimes even forestry and animal production, to do more climate smart practices as well. So one system I worked in a lot, I thought I would use it as an example. It's a peanut cotton bahia rotation with strip tillage, cover cropping, and cattle grazing. So this is an integrated system that utilizes both perennial grasses, annual crops, cover cropping, reduced tillage. So it has a lot of those components. And I really think the systems approach is really what we need to do. And obviously systems will differ for every soil and ecoregion that we have. So after this system was established in around 2004, and after the system had gone through at least 4 to 6 years, about 6 years, I think is probably more appropriate, we started seeing the need to reduce fertilizer and irrigation, about 25%. And this occurred, along with the organic matter, soil organic carbon increase over time. So these two things kind of went hand in hand, which is exactly what we're trying to say with these climate smart practices. We also did a study looking at greenhouse gas emissions from the soil, not from the animals, but just from the soil. And we found that in some cases, actually, when we were grazing, the soil actually became a sink for some of our nitrous oxide as opposed to a source or emitting, compared with our control cotton peanut with tillage and cover cropping with no grazing. So I thought that was kind of interesting. So we really do see some of these systems, working. We also saw yields that were consistently equal or greater than the traditional system, up to 80% greater yields in the peanuts. I think it was up to 50% in the cotton. So that's also a benefit. The problem was it took about 6 years to start seeing those results. And we did a lot of interviews with the farmers and some economic studies, and really, it was interesting. We actually did the economic study, but we actually did a little bit too early. We did it in year 4 through 6, and it was only starting in year 6 that we really saw it taking off. So that was one of the things that was kind of disappointing. It showed that there was no real economic benefit to the system at that time. I think we need to redo it now. Maybe we could see the economic benefit because we started seeing a lot greater yields after the fact. But one of the, at least in the Southeast United States where this study was conducted, we saw problems with adoption because people didn't feel like they had land that they could do both animals and crops. The animals were located at different locations or not contiguous. It was too hard to move the cattle around. They had rented land, lack of fencing, things like that. So I actually changed my region of study to Texas, which is a little more integrated in their animal crop production in a lot of areas. And so one of the areas that I'm in, we are now adopting some integrated row cropping and cattle production systems to see if that is working. So we're trying to, I think that's more likely to work there. So that's kind of my upcoming research. But a lot of these leads into the main problem with a lot of these systems is adoption. There is a cost with getting this started, and who's going to pay for that? The first couple of years, you might not see that benefit in organic manner. You might not see that benefit in being able to back off on the nitrogen or the irrigation. So who's paying for the cover crop seed and the herbicide for your cover crop? Who's going to pay for manure management infrastructure? Who's going to pay the additional labor to manage those cows and those different animal systems? And because a lot of the animal systems require stubble height management, pasture scoring, things like that require a little bit more management. So who's going to pay for that? I think that is the biggest question that farmers have. And then how do we overcome some of the regional and commodity specific challenges? Some of those problems might not even be real. They may actually be myths. For example, in the region I work in, there's a lot of myths that cover crops are stealing the water, or the cover crops are reducing the cash crop yield. And my research and some of my other colleagues, we don't see the cover crop actually stealing water, maybe for like the first week, but as soon as we get that first spring rain, it usually disappears, and then there's more water for the rest of the season. And reduced cash crop yield, I have not seen that in my region. I have heard of other researchers see that in their region, but it wasn't due to water. It was usually due to some other disease or some other thing that, again, so we need some pest that we need to understand in that specific environment. Another problem I've seen that I actually don't hear farmers talking about it. Well, I take it back. I do hear farmers talking about it, but we have a long-term rotation where I work, and it's been in since the 80s, and there's some compaction issues. Now, these soils do not have any cover crops on them. And the other thing is when they do because they're such small plots, there's a lot of traffic over them. And so I really think that the problems are actually with the inherent design of the experiment more so. But I do hear people occasionally talking about compaction issues with no tillage. Maybe strip tillage in that case would be a better option for you, or occasional tillage. So these are things we need to come up with solutions for to address them. Don't just ignore them and say, keep doing no tillage. If there really is a problem, we need to address it. And we need to figure out, I mean, that's the only way we're going to figure out how to incentivize change for these farmers. So we need to come up with soil, climate, and crop-specific adoption recommendations, or animal-specific, depending on what's going on. We need to come up with these. And then the last thing we need to figure out is we need to figure out how, if we're really going to monitor carbon in the soil and greenhouse gas emissions, right now, it's very expensive to do that. Even for me as a researcher, to do a good job, I feel like that's most of my budget. Some of the equipment, the analyses. You know, if you want to do greenhouse gases, you need these eddy covariance towers. Sometimes they're $300,000 each. This is not something a farmer is going to be able to do. There's some cheaper ways to do it, but it's labor intensive. So what are we going to do? How are we going to really figure out if we're maintaining these? So this is important. So what are our opportunities? On the farm, I see that we need to think about those farm systems. You know, what is integrating as many climate smart practices as possible, but also thinking about those extra regions. What about those riparian buffers? What about those areas on the edges of the farm? Can we use those to store carbon? Maybe those could be managed with different amounts of nitrogen. Maybe we could think of a precision ag approach to the entire farm and figure out, but include in that precision ag where we can store carbon. So I think that could be another idea. And that leads into where can we perennialize our farms? Where can we add perennial vegetation as many places as we can to reduce that? I realize a lot of crops are annual, so we can't do that everywhere, but that might be an option for us. And then I feel like and I do feel like in the last year I've seen a lot more, but when I was first started doing greenhouse gas work, there weren't that many people working on it. So we need to increase focus on greenhouse gases, particularly on nitrous oxide and methane. And that may be related to precision nutrient and water management, or animal manure management, or something that could really tackle those. I think that is something that we've had a lot of carbon focus for the last, I don't know, 30, 40 years, and not a lot of greenhouse gas. We need to think about how we can better incentivize, right? So maybe we can add an economic value to some of the practices, for example, grazing cover crops or some sort of integrated practices. We need to better define the cost and benefits to those producers because they don't see the economic advantages. So we need to better document what those cost and economic benefits are, and how long it's going to take to see benefits. That might have to be done regionally. And then one thing that I see sometimes in Europe, more so than I see in the States, is integration of clean energy production on the farm. You know, solar farms, wind farms, manure incineration or anaerobic digestion. These are things that are not commonplace in the United States, but I have seen elsewhere. So hopefully where you are, you're seeing those types of advantages, but this is something that is not worldwide, and this needs to be addressed. So opportunities off the farm. How can we add value to climate smart commodities? I know there's a lot of emphasis on carbon markets, and I think carbon markets are great, and in some places it's going to work wonderful where there's degraded soils or soils that could really benefit from added carbon. Where I am at, I don't see, you know, our 0.5% carbon is going to double and we're going to be at 1%. I don't know that's really going to make a giant difference in some of those areas. And in our region, it's soil specific. Some soils have 5% carbon and some soils have 0.2% carbon. So, but that is not going to help us, because when we think about the world food and fiber needs, that may not track with where we can do the carbon markets. So I don't think that that's a end all be all solution. I think it'd be better to work on expanding our commodity markets, branding and supply chain tracing, trying to come up with some climate smart commodity products that could really be incentivized through producers, similar to the organic farms. And I know that there are some countries and some commodities that are working on this. I also think that I never see any farm that is exactly the same as the next farm. I mean, does anybody know two farmers that do exactly the same things? I don't know very many of them that do that. Maybe there are, but I feel like that because there's no two farms that are the same, then every farm needs to have their own detailed plan with prescribed monitoring strategy. We need to come up with plans and help people, the farmers, come up with what the best option are for them, because doing carbon sequestration may be great in one area and not in another. Focusing on greenhouse gas reduction might be better in another region. Figuring out a clean energy supply might be another. So there are things that we could do to do a better job with that. I also think that our nutrient recommendations are not based on anything related to our management practices, and I think that precision nutrient recommendations might be very beneficial, and that way maybe we could reduce the over application of fertilizers in a lot of places. I have a couple of trials where I'm not seeing any response to nitrogen, and yet the soil testing lab keeps telling me I need to provide some, and I think it's because they're not taking account any residual nitrogen or nitrogen below a certain depth. So we need to do better at doing our recommendations. And then that gets into government policies and regulations that incentivize, again, that gets back to that incentivization. We need to work as a society to incentivize production at any way we can. And then the last thing is, right now, like I said, it's one of our challenges is it's expensive to monitor and evaluate carbon and greenhouse gas emissions. And so we need to figure out cost-effective solutions. And maybe it's a combination of a smartphone app capability with some detailed monitoring in, more 10 years, something like that. So these are things we need to think about. But together, I think we can come up with improve our climate smart strategies to work for every farmer. And so even a little bit in different areas could make a big difference. But we need to be strategic about it. We need to do better at measuring carbon and greenhouse gases and understanding our stocks. And we need to figure out how to create policies, markets, and strategies to incentivize adoption. Because if no one adopts it, it doesn't matter how good our strategies are or how good our measurement is. We need to get people to adopt it. So I want to thank you. If you have any questions, these are just strategies that we're working on in Texas and in the United States. And so I just recently traveled to Scotland and at the World Soil Congress, and I saw some great stuff and interestingly similar things that I'm talking about today. So I feel like we're all working on this together, and I think collaboration is the way to solve this problem. Is we need to work together to solve society's issues. So thank you.